Hi, it's Jan Beta and we're going to take a look at this HH Electronic MX900 professional PA power amp today. The reason for me looking at this today is that the power amp we used in our rehearsal space for my band broke down. Probably something wrong with the transistors in there. And I remembered that I had this in my basement for around 10 years or so. Didn't really test it in a while. It worked when I got it. This is a relatively small professional PA power amplifier. This is from the mid-90s. This unit was made in 1995, I believe. 300 watts per channel, 2 channels into 8 ohms, or you can bridge the channels and have 900 watts into 8 ohm mono. Very beefy unit, 16.5 kilograms. I bought this from a co-worker some years ago, and this was actually used in a kind of church environment for most of its life, and when they upgraded their system to something digital and better power amps and things like that, I was able to buy this for really little money. We're going to clean this up thoroughly and have a look at the electronics and try if this still works actually. Let's have a look at the basic functions of this. So this is a rack mount unit, of course, because it's for professional use on stages and stuff like that. So you would usually get these in this 19-inch rack mount form factor. Some of them are much bigger, of course, if they have higher output. This is the original volume knob. This is one that got replaced, and this doesn't fit really, so it doesn't really do anything. Beefy power switch. Bit of metering. There's a green LED for signal coming in at all. We have a peak red LED and a yellow LED for when the limiter is setting in, that is built into this unit to protect your speakers. We also have separate LEDs for mono and a protect LED that is probably going to light up before the relays click into action and put the output to the speaker terminals. On the back of the unit we have some spider webs. We of course have a mains socket here. This is the 220, 240 volts unit with a 10 amp fuse. There's a fuse holder here. You can lift the mains earth actually with this little switch, which is sometimes useful if you get hum. We have speak-on terminals here, the professional terminals to connect PA systems. We also have these screw-on terminals to connect bare wires or banana plugs actually. These are a bit bent, so we're probably going to do some work on that. A fan that is temperature controlled. No idea if this still works. We have a VCA controller here, so you can control this from a remote, a cabled remote externally. Can put this into stereo or bridged mono mode. We have limiter switches for both channels separately, which is pretty nice. These are the inputs, symmetric XLR inputs and symmetric 1/4-inch jacks. And that's about all we can see from the outside. I'm going to do some cleaning before I even open this up, but we're going to look inside this, of course, in a second. First of all, let's get rid of the spider webs and some of the dust that gathered on this. Just using my vacuum cleaner and a brush for that. Oh, there's something burned there. That's not good. Going to have to take a look at that. Let me take a couple of seconds to thank the sponsor for this video, PCBWay. my favorite manufacturer of prototype PCBs of all kinds. They can also do 3D printing, sheet metal fabrication, injection molding. They can populate your boards for you. Basically everything the tinkerer needs. Pricing is super reasonable, delivery is fast, and they are very friendly people to work with. So I highly recommend checking out the link in the video description in case you're interested in such things. Back to our power amp. I actually have this sitting on the front part now, which has these handles, so it's no problem, it's very stable. Just want to show you the insides. The first thing you want to do when working on one of these is to discharge the capacitors. In this case, there are four 10,000 microfarad 100 volts capacitors. These are for smoothing the voltage from the transformer together with the huge full bridge rectifier. That's this square thing down here. You want to discharge these because otherwise they are going to output 100 volts, and 10,000 microfarads is a lot of time that these are going to hold that charge. In this case, they are probably not going to carry any charge. But if you are working on a unit that has been powered up lately, you want to have something like this, which is my discharge tool. Basically, we have one side with a crocodile clip and one side with an insulated banana plug that I made years ago. Been using this all the time. So what I usually do is to connect this to one end. Doesn't matter if it's positive or negative. You don't want to touch any of this, of course. And then just connect the other side to all the connections on the other end of the equation. And we should be, because these are all connected together by these large metal plates, we should be discharging them all at once like this in this case. You always want to make sure that these are discharged with a multimeter. Can just double check that. Just setting this to volts DC, and we should read close to 0 across our capacitors here. Yep, that's 0.0002 volts. That's not very dangerous anymore. Always remember to do that, otherwise you will get zapped when touching anything that's powered. You of course want to disconnect this from the mains while working on this also, but this is very, very important, especially on these high-powered devices. These hold a lot of charge, and that is potentially going to harm you in a bad way or even kill you. So what else do we have in here? We have the massive transformer, of course. This is a toroidal transformer and connections to the mains switch here on the front panel. We have our rectifier, we have our capacitors, and this is basically powering all these transistors here that are the power transistors. Of course, there's a lot of them, and they are all individually pretty powerful. These are BUZ905 and BUZ900 NPN and PNP transistors, because this is a Class B power amp section here, which just means that the waveform you are amplifying is divided into the positive side of the wave and the negative side, and those two parts of the wave are amplified individually by the push-pull configuration with the PNP and NPN transistors here, so you get more power. And this whole thing is not aimed at super high quality audio, it's more aimed at providing very high output. So that's clearly what this is all about. There's 16 4 times 4 of these transistors in here in the TO3 metal package, all screwed down to this massive heatsink here, of course, which is also perforated here, so there's some airflow. And then we have this top section here, which is our input board and the pre-amplification section. There are spots here for adding input transformers, I think, which is pretty interesting. This is where our audio signal gets in on this little board on top here. And then we have our preamp section, and the scorched part is actually two Zener diodes that I'm going to have to check. We saw that scorched circuit board on the backside. It looks decent from here, and these xenodiodes get really hot in operation because they are going to sink a lot of voltage that's going to be dissipated in heat, basically, all the voltage that is not used. So these are naturally getting pretty hot. These two resistors here on top there are for bringing that current and voltage down for the xenodiodes. I think these xenodiodes basically see the voltage directly from the rectifying circuit here. So that's, I think, around 90 volts, so thereabouts. And these are 15 volts xenodiodes that provide the supply voltages for the preamps. And they are using TL072 chips. For that, these are the pre-amplifier chips. These are standard parts. You can tell by the fact that these are all socketed that this is actually a professional unit. And there's several relays here. These are the power relays for the speaker protection circuit. And we have another relay here, which I think is for one of the stages being powered on delayed. I'm not quite sure what that does. One of the initial things I always like to check with these, because it's super easy to do, is to check all the fuses. There are some of these glass tube fuses on here. There's even fuses to protect the drivers, so the preamplification stage. These two are for the driver circuit, which is super cool. And there's the mains fuse, of course. Sometimes there's also fuses to protect the speakers, in case the relays fail in some way and there's too much current flowing, which is of course also a sign for this being a professional unit. And these extra fuses for the driver section alone are always a very good sign. It's very well made, it seems. So let's check some of the other fuses. I think we have some more in here somewhere. So we have the fuses for the actual high power stuff here. They're all lined up next to this. It's very difficult to film, but I'm just going to check them all. And in case all the fuses you can find are good, like in this case, probably the amplification unit is halfway okay and there's no shorts in there, but we can still check the transistors here in a very quick and crude way. So I'm just going to keep this in continuity testing mode. And in case these transistors fail, these are the TO3 transistors we've seen from the front side. Usually the failure mode of these is that they just short out completely in one direction or in all directions. So you can just check connectivity between the pins. These have three connections basically. One connection is the casing in case of these TO3 transistors, so you want to check that. Nothing wrong with these, I don't think. And of course there's two channels in these. So this portion here is for the left channel probably, and this is for the right channel. In case one of your channels doesn't work, this is where to look. And these are also standard transistors that you can still easily get. I want to check these diodes where it scorched the circuit board here though. I think this might just be normal and I'm just going to do some little cleanup work there with some isopropanol. There's resistors over these diodes basically that sink a lot of heat, and the diodes are going to sink a lot of heat. So this could just be normal because this is so old. I'm just going to check the diodes with the diode check mode quickly. You can't really check xenodiodes in depth, but at least we're going to see if they are shorted out or burned out. This is really difficult to film. But I have my multimeter in diode testing mode now. And I'm just going to check these the right way around with the ground to the ground. And we're going to see the forward voltage. And that's roughly equivalent for both of these, around 0.6 volts, 0.7 volts. Those should be good actually. Another thing we can do is to set the bias. I think that's in my circuit diagram, which I printed out here. This is the only circuit diagram I could find, these are all diodes here, D27, D28, these are Zener diodes, 15 volts. These are our 1K resistors to bring the voltage, which is actually minus 90 volts and plus 90 volts. So that, I assume that's the voltage output by the rectification circuit there, just right from the transformer, basically. And the 1K resistors are bringing the voltage down and the current down for the Zener diodes. And then there's some more filter capacitors here, and we have our plus 15 and minus 15 volts rail, which is then used for the 072 chips, which are basically differential amplifiers. So they need a negative and a positive voltage. And of course, the cleanest way to get clean DC voltages are Zener diodes with some filtering before and after that. So that's a very good circuit, audio quality wise, but of course it gets really warm in use. And I think that's what we've seen with these scorched circuit boards there. One thing that I also like to do when checking these is to just see if the heatsink compound here is still good. And you can basically just use your finger to see if that still has some, if that's completely dried up or if it's still wet to some extent. And this seems to be good. It's still smearing on my finger here. This is basically a silicon-based heat transfer paste that's under all these transistors. And of course, the cases of the transistors, because they are one of the connections on the transistors actually, is insulated from the heatsink, so they don't all short out. There's a thick plastic layer under there insulating the casing from the heatsink. This is a grounding point, basically. Literally star-shaped ground, which is always the best way to prevent hum. One center ground pin where all the audio grounds are connected to. And I think in this case, it's also connected to mains earth, unless you lift the earth from the mains, which this has a switch for. In some cases, in live use, you get hum, depending on what else is connected to the same mains circuit. So you can lift the ground on this, which is of course not recommended because the whole casing is not going to be grounded. Maybe they made it in a way so that the casing is still grounded and just the audio ground is lifted, which would be the best. And probably that's what they did in a professional unit like this, so you don't get shocked. But the audio ground is going to be separated from mains earth. These are 30 amps, 250 volt rated, 24 volts switching voltage relays for the speaker protection here. They can switch up to 30 amps, 250 volts AC voltage, and AC is what we are switching here because it's an audio signal which is always fluctuating around the ground line basically. So it's going positive and negative. These are super beefy. Of course, because this is a super beefy amplifier. And of course, this is where our mains fuse is. There's an extra fuse holder directly next to the mains input. We're going to check that quickly too. There we go. So this is just holding the fuse in place. This is a 10 amp fuse, which is also not a glass fuse, but protected. I think they fill these with quartz sand, so you don't get any glass shards all over your circuit. Very nice, high quality fuse, of course. Let's see if that still works. It should be good. Every other fuse was good. And if this breaks, something is wrong with the power supply. It's good. So all the fuses are checked. Just going to lock this in place again. And we're ready to give this the first power on, probably in ages, in decades. I don't know when this was last powered on. I'm using this little device here, which is a so-called dim bulb tester. And that is an incandescent light bulb connected in series with the mains. That we have the mains going through the light bulb and to this socket here. And this goes to the power amp. So in case something is wrong, we're not going to burn all the transistors because this is limiting the current. And what should happen, if this is working completely, we should see this lighting up pretty brightly and then going lower. Just going to turn the volume down here completely. This should go brighter, the resistance of this is going to increase, and then this should go dimmer and stay lit, basically. I'm not sure if this is going to be enough for the inrush current that this takes. Maybe this light bulb is going to just burn out we're going to see. This is just a 60-watt light bulb. But yeah, probably it's going to work fine as long as we don't run anything on the output of this amplifier. So let's see what happens, I guess. Fingers crossed this thing still powers on fine. This is just to test if the basic unit works and if there's any shorts in the power amp section. Let's see. Just going to give this some juice. And there we go. And even the relay is clicked. We have a peak. The fan is running and our light bulb was bright and now it went low. So this is not running at full power now, of course. I'm not sure if this peak light, maybe we have a problem with the inputs there, but we're going to see, maybe that's just because this thing is not getting all the juice it needs. It seems to work fine. I'm pretty confident that we can run this at full power now and see what it does. So let's do that, I guess. The dim bulb tester just reacted as expected for a working unit. So this seems to be basically okay, except for that one peak light on the left channel that is a bit worrying. But yeah, that could be a lot of things actually. Maybe something's wrong with the input section there. So I'm just going to hook this up directly to the mains now and power it on again, I guess. And see what that does. Maybe it blows the fuse in my lab here. No, it didn't. And now the fan runs a lot faster. But we still have the peak light here, that's not good. But at least it seems to be basically working. We're going to check the inputs and outputs. And even the relay is clicked on, so there is something right about this. I think we should just run some audio through this and see what that does. And I'm going to get my old analog oscilloscope out, I guess. Because that's nicer for audio stuff. And I love it. So this is the setup now. I connected a load to my outputs, to the speaker terminals, and I connected a frequency generator, which in this case is my old iPad, generating a 1 kilohertz sine wave to the inputs here, and I've connected the oscilloscope, which is an old HAMAC, which I love, HM305 analog scope with some digital capabilities that I don't really need for this purpose. But yeah, the load is pretty important so that the amplifier actually sees something on the output, which sometimes helps it working correctly. And the scope is connected to the load, basically. This is also to protect the scope from seeing any hilarious output. I am just going to power the amp on and see if this gives me an output and how it looks. Volume pots are in the 0 position for now. Just going to see what this gives me and if I can see anything wrong with one of the channels. I also sprayed some contact cleaner into the volume pots and some of the connectors here, just to make sure that these make good connection. This is currently set up to 20 volts AC. Okay. Still working. Don't get anything on the scope actually, obviously. There we are. That's our 1 kilohertz wave. And the potentiometers are dirty, so we have to clean those again. And the fan is pretty noisy, but that's to be expected for a little fan that old. So I'm just turning up the volume on channel 1 now. This is the one that gave me the peak signal. And this is channel 2. Should be the same frequency. Yeah, this looks pretty clean to me. The peak indicator there, not sure what that is all about. Yeah, but this looks like it's working correctly. The waveforms look clean. The levels are roughly the same. Yeah, and if I turn down channel 1, which is this lower one, this is the channel the oscilloscope triggers on, so it won't give me anything. Yeah, potentiometer is already cleaned up a bit after moving them around a bit. So yeah, this seems to work fine. Apart from the fan being a bit noisy, but that's normal and it's actually blowing out quite a bit of air. That's good. I don't know why the peak thing is on permanently. Probably there's a capacitor there that's broken or something like that, but it's nothing to worry too much about, I guess. So probably we can hook up some speakers, some actual small speakers, and listen to some audio signal. So I have connected my studio test speakers here. Let me just fix this. This is like pushed, squished together. And usually you can just carefully get a screwdriver in there and bend it outwards slightly. But you want to be super careful with that because this is aluminum usually, so these are going to break pretty easily. I think that's all right. As I said, this is not a complete restoration, just some things I wanted to point out. I usually do checking these. I have some music running on my iPad, actually among the bits by my friend Focus 10, who provides the music for my channel. So let's see if we blow up the speakers, which is of course super easy. These are just JBL Control 1, so not very PA-like speakers, just regular stereo speakers. So we just want to give this very little juice. But it works pretty nicely. Can barely turn this up. Barely touching something slightly above minus infinity. Of course, this outputs a lot more than these speakers can take, so I'm not going to go berserk on that. And I don't know why the limiter is setting in. Maybe I should... Let's just turn off the limiter, I guess. Oh, that just means the limiter is in place, I guess. Yeah, I think that's what it is, probably. So all that's wrong with it is the peak LED on the left channel here, on channel 1. Both channels work, the fan works. It does look super beat up, of course, but I'm satisfied with this result. Just going to let this run for some time and listen to some music. It doesn't sound awesome, of course. Some of the hi-fi stuff I've been testing here sounds way, way better than this. As I said, this is aimed at providing power on the output and not sounding particularly nice. Focuses on amplitude and not necessarily on anything else. So one thing I could do is to set the bias, or at least check that. I think I want to do that as well. So in order to adjust the bias for both channels, there are these potentiometers or variable resistors, PS4 and PS3 for the left and the right channel. And there are these test points, T1 and T2, on both of them, T1 and T2. And you can just barely reach your probes and stick them in there, which I suppose is what I'm going to try. Basically a three-hand operation, but I think I can get away with that. I'm just going to adjust these for 800 millivolts. That's what it says on the schematics that I found, which is the only piece of the schematics. There's not everything on the schematics, and it's not a service manual or anything, but this is at least a setting. I know what to set this up for, and that's the bias. Let's do that. So let's see what we get here. Yeah, that's 700 something. That's pretty close to what we should get. Just setting this up to 8. These are high quality parts, the little trimmers there, because this is a professional unit. This is not your run-of-the-mill audio amplifier. Yeah, 803 millivolts. Let's do the other one. I'm just going to switch this off while I change the position of the probes so we don't get burned. This is a plastic screwdriver, by the way. It's a specially made screwdriver for setting up things like this. So let's see what the other channel does. That's 0.75. Yeah, that's also pretty close. Should be this trimmer. That's pretty close. And usually you want to run this for a while before you set this. But this seems to not be shifting much. So yeah, unlike audio amplifiers of other kinds, the hi-fi variety, this doesn't shift at all, basically. After like a couple of seconds of turning this on. We still have our peak LED lighting up, unfortunately. But yeah, I guess that's something we have to live with. I don't really think it's worth dismantling this whole thing here. I'm not sure if that LED is even on my schematic here. I might make another episode about this in case I figure that out. Or if anybody knows which part to check. I guess it's just a capacitor that's gone leaky or something, although they all look fine, but you never know. This is like 30 years old now, nearly exactly. 1995 unit. Still going strong, seemingly. So, cool. That's all I wanted to know and all I wanted to check on this. Yeah, maybe somebody gets something out of this. I'm sure not many of you have looked into one of these in person, so maybe it's interesting to just see what's in a 1990s professional amplifier. Nowadays, most of the amplifiers are Class D. That means that's a duty cycle based amplification, much less power consumption, much lighter, same output basically. The Class D amplifiers have gotten so good that they are actually usable for professional audio stuff. So most of the things you find these days for these power amps for PAs are digital amplifiers. But I guess there's still many of these old school things around. And if you just need some oomph for your PA, these are probably the cheaper option. Just get a used one of a good brand of these analog amplifiers and you are going to be fine. And I guess these are more sturdily built than the new ones, judging by everything electronic built in this decade. But I digress. Thank you so much for your time. I hope this was an entertaining video. More retro computery stuff coming up pretty soon. Special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. The links to that are in the video description. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye. And of course I'm going to have to close this up again. I'm not going to use it like this in the rehearsal space, because people might get killed. But that's just a matter of putting the plates back on and putting the screws back in, so it's not that interesting. I'm going to do that off camera. See ya!